All right. As you know, things have changed. We're now grading your geometry work. The grading starts last week, the week of April 13th. So if you're a few of you that are way behind and didn't do the work from March 30th or April 6th, you still should do that because those problems are going to be on the final and you're going to want to get as best score as you can on the final. But those homeworks aren't counted towards your grade. So starting last week, the grades start, and then obviously this week and moving forward, all the assignments will go towards your grade. Each day will be worth 2 points. So the week assignments will be worth 10 points. And if you do all the assignments, you already have 70% out of 100, and you only have to get a 66% on the final, so it shouldn't be too bad. All right. Today's homework is similar to yesterday. The warm-up problems are a review, and they are the type of problems that you're given a center and a point on the circle, and you have to find the equation of the circle. So here's an example of that. The center is 1, 6. The point on the circle is 4, 4, so I drew a little picture for you there. And to write the equation of a circle, all you need is the center and the radius. So we know the center, we just have to figure out what is the radius. So the radius is the distance between those 2 points from the center to the edge of the circle. So how do you find the distance between 2 points that are diagonal from each other? You use the Pythagorean Theorem. How far down, how far over to get from one point to the next? Well, to go down from 6 to 4, you had to go down 2 spaces, and to go over from 1 to 4, you had to go over 3 spaces. So it's down 2 over 3, which I kind of wrote in there. It's a little cramped, but you can see you went down 2 and over 3. So you square those two, and you get 4 and 9, and you add them together, and you get 13, and then you take the square root. So the radius is the square root of 13. 4 plus 9, 2 squared plus 3 squared. Now, when you write the equation, it's x goes with the x-coordinate of the center, which is 1, and you change the sign. So it's minus 1 squared plus y minus 6 squared plus the square root of 13 squared. Remember, the equation of a circle is Pythagorean Theorem, so you're squaring everything. It's the x direction squared plus the y direction squared equals radius squared, which is like the hypotenuse. If we draw a little triangle inside of our circle there, it's basically a right triangle. We went 2 spaces over in the x direction, 3 spaces up in the y direction. So how big was our radius? It was the square root of 13, but we have to square that. And when you square a number that's inside of a square root, the squaring it and the square root symbol cancel out. So you're just left with the number that's inside the square root. So that's the equation for that one. All right, this next problem is number 7 from yesterday's work, which some people had some trouble with. And the reason is, before you complete the square, your x squared and your y squared terms have to be 1, meaning the coefficient has to be 1. You see how right now we have 2x squared and 2y squared? You can't have that if you're going to complete the square. So you have to divide by 2, and you have to divide everything by 2. So that's what that second line is. I split all those terms in half. 2 turns into 1, 8 turns into 4, and so on and so forth. All the way to 46 turns into 23. Now you can complete the square. So to complete the square for the x's, you take half of negative 4 and you square it. So that's what the negative 2 squared in parentheses is. And to complete the square for the y's, you take half of 6y and you square it. So that's what the 3 squared is. And those two numbers turn into 4 and 9. So if you add 4 and 9 to the left-hand side of the equation, you have to add 4 and 9 to the right-hand side of the equation. That's why I have 23 plus 4 plus 9 over on the right-hand side. I added a 4 and a 9. I'm going to underline them for you. So I underlined the 4s and the 9s on both the left-hand side and the right-hand side of the equation. So we're still balanced. We added the same thing to each side of the equation. Now you can factor your x's. They're perfect square trinomials. They're x minus 2 and another x minus 2, which is x minus 2 squared plus y plus 3 squared equals 36. So that's how you did 7, and that number 8 yesterday was similar to that. You had to divide by 2 first before you got going. All right, today's work is basically the same thing. It's still completing the square to find the equation of a circle, but you're going to start off with equations that look like this that are all mixed up. You're still going to have an x squared term, an x term, a y squared term, a y term, and a constant by itself. But before you start completing the square, you got to rearrange everything so that it's in order. So you want your x squared to be first, and then your x term, and then your y squared term. Well, the y squared term is all the way over on the other side of the equation. So when you move it across the equal sign, you got to change the sign. You got to add it. It's a negative y squared, so you have to add y squared over to the other side. So that's how I got right there. All right, and then negative 2y equals 64. So all I did was rearrange the terms that they give you all scrambled up so that it's all in order. Now you can complete the square. You take half of 8, which is 4, and you square it. You take half of negative 2, which is negative 1, and you square it. Those two numbers squared are 16 and 1, so you got to add 16 and 1 to the other side. That's what these are. And 64 plus 16 and 1 is 81. So you end up with x squared. I'm sorry, x plus 4. This is like a mirror image here. It's hard to tell. All right, I got to look. All right, x plus 4 squared plus y minus 1 squared equals 81, and that's the equation of the circle in standard form. So pretty similar to yesterday, just one extra step here. You got to rearrange your terms so that they're in order, and then you do the same thing.